Hello, everyday statistics, and welcome to the last lesson of Chapter 1. Lesson 1.9, we're going to talk about describing location in a distribution. We're going to use a z-score to do that, and we are going to go ahead and use percentiles as well. So let's go through it. So we'll do what I was saying. We're going to find a percentile. We're going to look at a cumulative relative frequency graph, or an ogive, and we're going to look at a z-score as well. Here we go. So we got 25 students in Mr. Pryor's statistics class. So what they got on their first test, the bold score there is Jenny's 86. You want to know, how did she perform in this test relative to our other classmates? And that's a question we'll be able to ask, or answer, I should say, once we're done learning the tools that we have in this lesson. So if we're going to describe location in a distribution using percentile, what we're looking is the percent that are less than the individual's data value. So if I ran a race and my time was in the 90th percentile, that means that I ran the race faster than 90% of the people that ran it, which would be pretty good. So it turns out that with Jenny's, back on the other page, we counted 21 out of the 25 observations that were below. And so how did we find this 84%? We said 24 divided, my bad, 21 divided by 25. And that's going to give us the 85%. Okay. Yeah. Okay. We can also look at these percentiles using a cumulative relative frequency graph. It tells us what percentile each person is at, or each value is at in a graph. Pretty nice. Let's go ahead and just see it and use it. In order to get this graph, you have to actually make this chart that gets cumulative relative frequency. So and we can go over this. I believe we're going to make one of these here in a second. Or actually, now that I think of it, you're not going to have to make the table. You'll just have to understand where the values come from in the cumulative relative frequency graph, right? So we have frequencies, right? We could make a histogram with all this stuff, right? We have some bins, we have frequency. But then what we want to look at is kind of like the relative standing of it, right? So how many are at or below that, right? So if there are 9 at or below, right? Since there are 9 values here, right? Then we will calculate a then we're dividing the number that are at or below that value by the total, and that gives us our percentile. You don't need to know how to make one of these. What you need to know how to do is how to read one of these. So for instance, right, if I wanted to know, hey, what age at inauguration would be at the 50th percentile, then I could just go over here and go, oh, my bad, I'm looking at it, I'm going to 50th percentiles right here. So I would come over and I would say, hey, it looks like a person who was 55 at inauguration has at about the 50th percentile. That's how we'll read that. So called the cumulative relative frequency graph. I also like to call it an ogive. Other people do too. It refers to the shape of the graph. It's a little easier to say. So another way that we'll describe a location in a distribution is by getting a z-score. So we can look at a percentile in terms of its cumulative relative frequency. In other words, how many values are at or below that value. Or we can look at it in terms of standard deviation. How many standard deviations away from the mean a value falls? In order to calculate that, we'll use this formula right here to get a z-score, or a standardized value. So this one, with Mr. Pryor's test, right? We had, what's her name? Jenny, 86. We want to know, so we can also describe where it falls in the distribution in terms of how many standard deviations away from the mean it is. So the mean score was calculated. Apparently that was our mean. This guy is Jenny's score. If the standard deviation was calculated, we would divide it by that standard deviation, and that would tell us a standardized score. So we would say about 1 standard deviation above the mean. So the way we're going to interpret that is to say that Jenny's test score is 0.99 standard deviations above the mean score of the class. I'm excited to do an example of this for you. So it looks like we've got an ogive, and this is for median household incomes in 50 states. Kind of get the whole picture here. All right, so right away, we're going to read this ogive. We've also been given some fantastic information. We've been given N. This is our sample size. Essentially, how many total, right? How many observations total? That's what N is. Observation, is it? Okay. Anyhow, we've got that information, 50, because there are 50 states. And then more importantly, we know our mean and our standard deviation. That'll help us to calculate a z-score here in a little bit. So let's answer number 1. At what percentile is North Dakota with a median household of $55,766? So 55.7, you know, maybe that's right about here. So we're going to go up, and we're going to see that, I mean, gosh, that's hitting about, about where that dot is, right? So I would say, and you're going to estimate, right? I mean, it's not perfectly in between 60 and 80 there, so not 70. So let's estimate maybe 68. Sure, why not? As long as it's close enough, we're good. So at what percentile is North Dakota with a mean income? I would say that North Dakota is at the 68th percentile. That easy, y'all. Okay, I'm looking for household incomes, and then I draw a dotted line up. When it touches, I draw a dotted line back to my axis, and I look at where that value is. That's how it's done. How about if we were to estimate and interpret the first quartile of this distribution? Okay, all right. Quartile 1. Well, first of all, we got to think about what percentile is quartile 1 at? Well, isn't it true that the quartiles split the data up into 4 even parts? That's why they're called quartiles. So 25% of the data is at or below quartile 1. 50% of the data is at or below the median. And 75% of the data is at or below quartile 3. So then what we're being asked for is what median household income is at the 25th percentile. So if I estimate that this is 30 here, right, that's about 30, then 25 is going to be about here. Now I'm going to go the other way. I'm going to make a dotted line and then go down. It looks like we're at 45. So let's go ahead. Now we've got that estimated, let's go ahead and also interpret it. So quartile 1 is $45,000. Let's interpret that. A household with an income of $45,000 has a larger income than 25% of households. Nice. That will work. 25% of all households. Let's just say of households. We're looking at households in the study, I believe. Fantastic. There we go. It has been estimated and interpreted. Let's get to number 3. All right, number 3. Let's find and interpret the standardized score, Z-score, for New Jersey with a median household income of $66,692. So this guy, so we're going to use the formula Z equals X minus my mean divided by my standard deviation here. All right. So this is X. This is X bar, and this guy is S of X, the standard deviation of my sample. So we've got $66,692 minus $51,742.44 divided by my standard deviation, which is 8,210.642. We're going to calculate this, get a z-score, and then we'll go ahead and interpret that z-score. All right, so I put that into my handy dandy calculator, and I got 1.821 approximately. I had to do some rounding there. So how would we interpret this value? Well, we would say that that New Jersey's median household income, so write it down here, New Jersey's median household income is 1.821 standard deviations away from the mean. We'll just say from the mean. Awesome. And that wraps that up. That's all you really need to know how to do for chapter 1.9. You're going to be able to, you're going to need to find and interpret a percentile, and also find a percentile from an ogive or a cumulative relative frequency plot. And then you're also going to have to be able to find a z-score and interpret that in context. So there you go. And those are the things that we did today. We found percentiles, all that stuff. It went really well. Thank you guys so much for watching. I hope you're having a great day. And if you're not, I know it's going to get better.